welcome to OsteoBItes. We'll give a couple minutes for everyone to just enter our virtual room and get settled. And happy Thursday. We are so happy to have you here. Thanks for taking time out of your day to join us. My name is Christina Iptoma, and I am mom to OsteoAngel Dillon and Director of Scientific Programs at MIB Agents. And today on OsteoBItes, we are talking with Dr. Brian Crompton about the Children's Oncology Group's initiative, Project Everychild. Thanks so much, Dr. Crompton, for joining us on OsteoBItes today. We're thrilled to have you. And I also want to thank Vicki for joining us as our panelist today. Vicki is an osteo warrior and MIB Agents Junior Advisory Board member, and I won't let her introduce herself with some kind of fun news that she was actually just sharing with me over chat. But I will let you share that, Vicki, because that's pretty awesome. A little bit more about our guest today. Dr. Crompton is a pediatric oncologist and physician scientist. He is the research co-director of the Solid Tumor Center at Dana-Farber Boston Children's Cancer and Blood Disorder Center, and he's also an assistant professor of pediatrics at Harvard Medical School. His research focuses on utilizing genomic and proteomic technologies to identify and validate new therapeutic targets for pediatric solid tumors and to develop non-invasive biomarkers of treatment response and resistance in these diseases. His lab has developed new approaches to estimating circulating tumor DNA levels from liquid biopsy samples from patients with pediatric solid tumors. And he is here today to discuss a COG registry initiative called Project Everychild. And before we get started, we have a couple of announcements. If you are a clinician or researcher with an interest in osteosarcoma, we invite you to join Turbo, which is our virtual tumor review board for osteosarcoma. Our next meeting is September 14th at 3 Eastern. And if you'd like to be added to the calendar invite, or if you're interested in submitting a case, we'll put a link in the chat where you can request more info. Turbo is open to doctors only, but patients and families are welcome to ask their oncologist to submit a case on their behalf. And we have some fundraising events coming up. We have our virtual Outrunning Osteosarcoma events, so you can run, walk, cycle, and help us cause a cure. Just rally some friends for a 5K, 10K, or half marathon now through September. You don't even have to do it all at once. You can do 15 minutes a day. You can do it on a treadmill, on a stationary bike, if that's easier. And you can do it in person or virtually. And there's some cool swag involved too, and we'll put the reg link in the chat. And then for September Childhood Cancer Awareness Month, we'll be launching our very popular gold mailbox bows shortly. You can make and sell bows in your community or make a donation and get a beautiful bow for your mailbox to raise awareness for pediatric cancer and show that you care. And we'll put some more information in the chat on how to get involved with that too. And I would like to thank our sponsor of this episode, the Osteosarcoma Institute, OSI, which is a nonprofit organization led by osteosarcoma experts from top US cancer centers who together are concentrating on the cure for osteosarcoma. The mission of the OSI is to dramatically increase treatment options and survival rates in osteosarcoma patients through identifying and funding the most promising and breakthrough osteosarcoma clinical trials in science. And in addition to advancing research, OSI also provides a free resource called OSI Connect for osteosarcoma patients. Their osteosarcoma experts can discuss available treatments, possible side effects, and provide helpful advice for getting the most out of your visits with your treating physician. This resource is available in English and Spanish and aims to help patients and families find answers to their questions. So thanks, OSI, and I'm going to hand it over to Vicki to introduce herself.
Hi everyone, so as Christina said, I'm an osteo warrior and a member of the Junior Advisory Board, and I had actually just mentioned in the chat that it is a year since my first diagnosis, so what a crazy year it's been, but I'm glad we got through the hard part of it. Yeah, and I'm starting at Villanova in about 3 weeks, which I'm very excited about. But thank you for being here, Dr. Crompton.
Oh, it's great to be here, and congratulations on getting into Villanova. It's a great school. All right, so this talk today, and thanks to everybody for being here. I'm sort of like a representative today. I mean, usually when I give a talk, it's about my own research. And this is a little bit of a different talk. I actually was fortunate enough to do an OsteoBItes about some of our liquid biopsy work several months ago. So I'm really excited to be back. This talk kind of came about because Doug Hawkins basically asked me to sort of represent COG on this, but Project Everychild is sort of like an enormous project that includes a lot of people. In no way do I want to give the impression that I'm somehow responsible or leading it. Responsible in the sense that happy to answer questions and help make things work, but I don't deserve the credit for this massive project. So, you know, I think before we sort of jump into Project Everychild completely, I wanted to sort of take a step back and talk a little bit about why having a registry and a biobank is so important, because that's what Project Everychild boils down to. It's a national, really an international biorepository for patients with pediatric malignancies. I showed some of these slides at the Make It Better conference, the Factor conference. So some of this you may have heard before, but hopefully it's good to sort of revisit. I think, you know, really good biology, which is what we need to get to better cures, comes from really good experiments. And there's different ways to sort of do good experiments. So I kind of bin them, I mean, this is a massive oversimplification, but I sort of bin them into three categories for the purpose of this talk. One way to think about doing sort of really interesting and very informative experiments is to do a very complicated experiment on like a single sample or a couple samples. And you can certainly do that now. Some of the technology we have, like single cell genomics, you know, you could imagine doing all these different single cell genomic things, experiments, all on a couple patient samples, and you're going to get, you know, sort of a mountain of data. And I think that that's really great for trying to get a quick hit on an idea, seeing if a hypothesis has any legs, or just generating a hypothesis to test. So these are really important, and a lot of people use sort of their local biorepositories to get enough samples for something like that. At Dana-Farber, we have our own pediatric solid tumor protocol. I actually am the PI of that banking study here. So, you know, we have our own, we're collecting samples from our own patients who are generous enough to contribute to research. You can also think about doing sort of simple experiments on a larger collection of samples. So, you know, maybe you believe that this one protein really matters in terms of either identifying a new option for therapy, or for, you know, predicting who's going to be successfully cured on our standard therapy versus not. And maybe all you need is one slide where you stay in that slide for the expression of the protein the way pathologists do. And so you just do a very simple experiment on a lot of samples. So that sort of generates a lot of data too, because if you have a lot of samples, even sort of a very simplified experiment can sort of generate a lot of data. But I think what gets most of us excited these days, and I think where the field is going more and more, is to do these complex experiments on very large collections of samples. And that basically, you know, if you've done step 1 and step 2, to really bring it home and make sure that we're creating compelling data that changes the way we do therapy, but also creates like a repository where people can go back and mine research data over and over again. We should be thinking about doing really complicated experiments in very large collections of samples. And that really requires multi-institutional collaborations, because as everyone here knows, you know, only so many patients with any one given diagnosis are seen at a single institution. But it also requires a lot of expertise to do the analysis, and how one group might analyze a really complex data set will be very different than how another group does it. So not only do we need to gather samples from a lot of different places, but after we've tested our primary hypothesis on these complex experiments from large sample sets, we really want to make it public so that other people with good ideas of how to analyze complex data, usually through computational computer algorithms, can try their approach and find something different, because we're sort of not really close enough to where we want to be in understanding the biology of many pediatric cancers, especially osteosarcoma. So where do you get large numbers of patient samples. And this sort of leads into why Project Everychild came about. So, if you look at where enrollments come from, and this isn't osteosarcoma specific, this is pediatric cancer specific. If you look at where clinical trial enrollments come from in pediatric cancer in Children's Oncology Group, only half of them come from the big institutions, the ones like lots of people think about when they think like Dana-Farber and these other big institutions where we have high volume, right? And I put that in quotes because, we still only see, a handful of patients with any given different sarcoma diagnosis per year. So half of the enrollments come from those big institutions, but then half of the enrollments come from 190 other institutions, right? Some of which may only enroll one patient on any pediatric cancer trial per year. But the patients are there. Half of the children who have cancer every year are being seen at an institution with a sort of lower enrollment rate. And we can't just say, well, we don't need those samples for really good research, because we clearly do. And so there's a couple ways to try to get access to tissue. One way is through clinical trials. So if patients enroll in a prospective trial testing this addition of this therapy to the standard of care, and patients are randomized to one or the other, that's sort of what people typically think of are big phase 3 trials. One thing you can do when you write those trials is include options for collecting samples for research. So that's in the context of clinical trials. Another way to do it is patients may not go on a clinical trial. They may just be getting what's considered the standard of care, which from a therapeutic perspective is like completely appropriate, and patients are getting the best therapy out there by doing that. But for them to then contribute tissue to research, they would then have to enroll separately on a banking study. And that in a banking study, there's no sort of clinical trial or treatment that's designated as part of a banking study. All it does is says that if there's any tissue left over from a biopsy or a blood draw that's not any longer needed for clinical care, what's left over can be banked for future research. And that's a banking study. And the reason these banking studies are becoming more important is that, back in the 90s, where there was like no standard of care therapy at all, 70%, virtually all kids who were diagnosed with a pediatric cancer eventually enrolled in some sort of clinical trial, because that was the only way to get therapy at all. Now in the data here only goes out to 2004 to 2015. It's more like a quarter or a fifth of patients who have a trial that's open for them at COG. And so a lot of patients receive standard of care outside of a clinical trial. And again, that's perfectly fine, because patients are getting the best therapy we have out there. And in some cases, in some pediatric cancers, that results in 90–95% outcomes. And that's pretty good. And so getting that standard of care is reasonable. We need to do better, obviously, in osteosarcoma, and we're working very hard to get a phase 3 trial open in the next few months for newly diagnosed patients with newly diagnosed osteosarcoma.
Dr. Crompton,
yeah.
Oh, sorry, just a couple questions about collecting samples from clinical trials. Would you say that most clinical trials are including that option to collect samples for research? I guess is the first question. And then second, for those clinical trials, do they have to be like a COG trial in order for those samples to then actually be collected centrally? I'm not sure. I just don't know for those trials, like if it's a pharma-sponsored trial or like what happens. I'm just trying to kind of get a sense of, well, clinical trials, once you start applying these filters, like how many samples actually would end up in a central biorepository.
So if you enroll in a Children's Oncology Group study, there's only one place for optional research samples to go, and that's to the Children's Oncology Group Biopathology Center, which is the repository for Children's Oncology Group. That's not necessarily the case if you roll on a trial that is, sort of single institution trial. Sometimes the early phase trials are very small. You only need to enroll, 10 patients over a couple of years, and that may be that it's only at that institution. And that could mean that the samples go, well, one, it may mean that they don't even necessarily include the option to contribute tissue to research, because it may be that that study doesn't have funding for that. Or it could mean that the industry sponsor needs tissue to understand the results of their study, and that's good use of tissue. So that's not, I don't mean that to be a negative. I mean, we need to understand whether if a drug is meant to hit a certain biomarker, that biomarker was there in the patients who enroll in the study, and those are the patients who responded to the therapy. So that's a good use of tissue. Or the institution that sponsors the study, if it's an investigator-initiated trial, may write in some biology aims and some option for banking. So the answer is really all of the above. It's possible that study doesn't include that. All COG studies now really do include that, and the NCI gives COG some money. The NCI is the funder for COG, just to make sure everybody is aware of that. And the NCI does include some funding for collecting samples on the phase, on any NCI-sponsored COG study. So most of those studies include the option, an optional question about saying yes to research. And if that's the case, then any tissue left over can be banked at COG. Okay.
Okay, got it. Thank you.
So the last point I wanted to make on this slide is just that, you know, if it's only a quarter to a fifth of patients who have pediatric cancer who are enrolling on a clinical trial, that means the other portion of patients need to bank tissue if they want to contribute to research some other way. So that's where Project Everychild comes in. And basically the idea of Project Everychild is that it's a banking study and a registry study that's completely, that doesn't rely on the existence of a clinical trial. So if you're at a children's oncology group, if you're a patient who gets seen at a children's oncology group center, which is the vast majority of pediatric cancer care providing centers in the United States, actually in North America, then there is an option, and hopefully an option that's presented to new patients always, to bank leftover tissue at the COG. And basically, if you say yes, then if there's tissue that's left over after the pathologists have sort of done the diagnosis, or made sure that the resection was complete and all that, then so that tissue can go off to the COG and get banked centrally. And then there's also some clinical elements. There's less clinical elements than a clinical trial, but usually it's diagnosis and age and demographics, and then outcome are collected and affiliated with each of those samples that goes into the bank. And that's obviously really important to understand whether, if you're doing a study using some of these samples and you want to know whether the thing you found is associated with, you know, good response to therapy or bad response to therapy, you have to know the outcome. So having some of those annotations to go with those samples is really key. So Project Everychild allows for all of that when patients consent to this. And it's disconnected from a clinical trial. Any questions on that before I move on to like what happens after a sample gets banked? Because I want to make sure we answer any questions about enrolling on Project Everychild and what it means to be enrolled in Everychild.
Vicki, do you know if you were enrolled in Project Everychild?
I wasn't, but I do know that I gave my tumor to, I think it was Columbia Research. So I don't know what program they have there, but I definitely banked my tumor. I know that.
So if a patient's at a COG institution, is it likely that they will just be presented with this option, or should they make sure to ask for it to say that I want to be enrolled in this project?
I'm not 100% sure whether every institution necessarily is as, at Dana-Farber, we basically try to present this to every patient who comes in as a COG center, but it's resource intensive, you know, and as much as everything at COG usually does get reimbursed to centers, you know, you can imagine that a government program maybe is a little underfunded. So the reimbursement that a lot of centers get from COG for enrolling patients on Project Everychild doesn't necessarily meet the entire cost of having a research infrastructure. So at the bigger centers like ours, where we're doing research all the time, we just sort of swallow the little bit of gap between what we're getting reimbursed and how much it actually costs, because we're doing other research anyway. So we're meeting with every patient about research no matter what. I think if you're at a center where that's less common, there's a chance that they want to present this every time, but in the heat of all the other things that have to happen when a patient has a new diagnosis, it may not get always prioritized. So I think people should feel empowered to ask for this. It doesn't require that you sign up before you start therapy. You know, pathology centers, pathology groups don't throw away tissue that's left over from a patient who's actively under treatment. So if you had a diagnostic biopsy or a resection at some point, it's very likely that there's leftover tissue. So even if you consent months into your therapy, you bring this up and say, oh, I really wanted to do this. Can I make sure some samples get to COG? You know, and you consent. Samples that were acquired, you know, months ago can definitely be sent on, and that's totally reasonable. One thing you just always want to be careful of course, is that there's enough tissue left over that if you ever need down the road to have that tissue analyzed because you need a different therapy approach or something, that there's always some retained back at your home institution. Most home institutions are like hawks about not letting the last bit of anybody's tissue go out for research. So it's usually not a problem, just worth bringing up. I guarantee you here at Dana-Farber, we never hand over we never exhaust any samples for research. So I think most places are going to be like that.
And is this, is it only fresh tissue, or can it also be the slides?
Oh, in fact, most of what we get from Project Everychild is fixed tissue, meaning it's on a slide or it's in a block. And the reason for that, quite honestly, is that, you know, I think we've started to recognize that if we try to make it hard for centers to contribute samples to research, we don't get very much. Mm-hmm. So we've now, I think over the last 10 years, spent, you know, a lot of places have gotten used to working with fixed tissue. We can't do everything we want to. You can't do single cell sequencing, for example, on fixed tissue. So we love frozen when it's available. But we can do a lot of stuff with fixed tissue now that we couldn't 10 years ago, because that's what's there. And if we had to make some of the technologies work on fixed tissue if we ever wanted to get anywhere with you know, sort of big data, generating big data. So Project Everychild will take blood. We're doing a lot of liquid biopsies, so they'll take multiple blood samples from different time points. They'll take fixed tissue and frozen tissue, all of that. We don't actually often request fresh tissue because that sort of requires it getting there on time and being used right away. And that's sort of that's just not the strength of Project Everychild. Other groups, like a lot of local institutions like ours, will try to use fresh tissue to make mouse models or to do single cell sequencing at a higher resolution. But that stuff is best done usually locally. So for most projects through Project Everychild, we don't need fresh. We just like frozen is best, but we'll take fixed for sure. Yeah.
And so it sounds like for sure, it's definitely never too late to enroll, because it sounds like you can always send that stuff. What about for bereaved families? Like, I don't know how long institutions keep those slides, but can they still
come back to that? Let's come back at the end. I don't think Everychild has a path for that. I don't think that there's enough options, to be quite honest, for bereaved families to contribute tissue. There are some sort of legal ethical hurdles that are completely artificial, because if a family wants to contribute samples, they should be allowed to, in my opinion. It's perfectly ethical. But I think there's the other place where I'm happy to I don't have any slides about this, but happy to have a discussion. The other place that I constantly sort of get inquiries about is from families who know their child is dying, and want to sort of contribute samples right after that. And that's not always the easiest thing to have set up. And COG is thinking about that, and a lot of centers are thinking about that. I'm not sure I have the perfect answer for how to go about that right at the moment. But I think it's such a potential gift that a family is considering something like that I think we need to work a little harder to make sure there's real opportunities to realize that gift and use it to its maximal impact.
Yeah, and I'll put some more information about this either in the follow-up email or in the chat if I can find it in time. But there is, I think it's CCTDI that actually does specifically have a program for that.
There's Pat Reynolds maybe group is maybe what you're talking about, where
this is up in organ. I think it's
Oh,
childhood cancer.
there may be more than one. Yeah.
Another acronym that I'm
Yeah.
of course not remembering right now, but I'll look it up and put some more info.
And also Pat Reynolds' group in Texas, they have a protocol, and it's loosely affiliated with COG, where they'll take autopsy tissue and try to immediately make a mouse model of it in a cell line, which basically means it becomes a tool for scientists going forward. So it sounds like there's more than one program, which is really, really great.
We also just had a quick question just before you moved on. Sabine asked, are samples from Europe collected? And if so, how can we send a sample from there?
I don't know if I know the answer to that. I mean, the short answer is for sure yes. I don't know that there's as organized an approach for that. There are sort of European level prospective studies, and they definitely, in the way that COG phase 3 studies ask for tissue, that tends to exist in some of the European multinational studies for sure. I think though for pure banking, that tends to happen on the country by country level. And honestly, the best way to learn about it, and it may happen at the institutional level too, very likely, the best way to find out about it is to ask. And I think most pediatric oncologists really want things to change and for us to find better therapies. That's sort of a universal feature of a pediatric oncologist. So they may not have thought to ask you, but if you ask about what the options are for donating tissue, leftover tissue for research, if there's something out there that they can help you get enrolled on, I'm sure they will. I'm sure they will. So I would just encourage everybody to ask their pediatric oncologist, how do I get involved in research? I think that step one will get you a long way most of the time. Okay. Well, feel free to keep asking questions about enrollment. We can come back to it, or you can interrupt as I go. I wanted to talk also a little bit about how do investigators then, so all this tissue hopefully is coming into the COG, and it is. How do investigators then with a really great research idea get access to that tissue? And you can imagine that it's a process that can be somewhat cumbersome. So here, this is how I envision it. This is sort of like a visual tool for thinking about how it used to be, right? So on the left is like a picture of a very long line at some sort of motor vehicle registration office where the line is so long that they've literally put seats down because they know it's going to take you forever to get through that line. So requesting samples and getting approval for samples can take a very long time, and you wait a long time to get samples. That's still true even today, although we've sped that up a bunch. Then an experiment happens, and that can be very different at very different labs depending on what the question is. And then data gets generated, and you can imagine that if you printed out the data set, it might be an enormous stack of papers. What we want it to be like is more like this, where in like a super ideal world, you go up, that's like a McDonald's kiosk. You hit what you want, you get your samples a few minutes later, you go to your lab, you do an experiment. That may take a long time or a short time, depending on the experiment. And then the data goes out into the universe. And on the right here, if you've seen Iron Man, the main character there has this amazing computer system where he can virtually touch things and put things together and make new Iron Man armor. And also I think in one of the movies, he invented a new element. So what we'd really love to do is make the data so accessible that basically anybody can play with it. And this probably is a little extreme of an example and unrealistic, but we are starting to make progress in making sample acquisition more realistic and trying to make data analysis more user-friendly. So one of the ways we're trying to improve getting access to samples and sort of get away from the DMV model is that we have, before my time with the COG, developed this group called the Quad W office. It's the Children's Sarcoma Biostatistical Annotation Office, which It's kind of a mouthful, but basically it's a group of administrators and statisticians who help investigators like me, but many, many others, apply for access to samples. And they sort of, when you come in, you say, I want 1 million samples with this characteristic, which is super rare. They're the group that says, well, we don't have that. Or we want 100 of these. And they say, yeah, we have actually 200, but you're a little underpowered, so you should ask for 150 samples instead. And then the administrators sort of ferry the paperwork through all the steps, make sure all the parts are filled out that need to be filled out, and make sure it's getting sent to each level of approval as the process goes on. And this is, I think, really made a major difference. The other thing the statisticians did in the first place is that the biorepository years ago was hardly annotated at all. So they took all the clinical data, this is all before Project Everychild, that was available, and they started to really annotate all the samples with it. Because if you have a bone sample and you don't even know whether it's osteosarcoma or Ewing sarcoma, you can't really do a research project. If you know it's osteosarcoma, that it's a patient who got this kind of therapy and the outcome was this or that, then that sample is instantly more valuable. And so the first project the statisticians at Quad W office took on was just fixing the annotation problem that the bank had. Now they're really focused on trying to get investigators who have a good idea access to this high value tissue collection. And this is the result, in my opinion, this is just the osteosarcoma publications that have come out of the office. Originally, the office was focused entirely on osteosarcoma. This was an idea that came from the Quad W Foundation, which I'm sure most of you know is an acronym for what would Willie want. And Willie Titchener was, he's an osteo angel, and his family sort of came together and had this really forward-looking vision of trying to make science happen better and faster. And they do it in a way that honestly is sort of under the radar with the statistician office, because it's not glorious work, but you can see the impact is just sort of enormous. It makes it's like the butterfly effect. You make things a little better here and all kinds of amazing things happen across the world. And so these are some of a list of the publications that are osteosarcoma specific that have come out of the samples collected through COG and with the help of the Quad W office. I wanted to just highlight a few that I think are really massively impactful. I think most people know that the NCI had 2 major sequencing initiatives as we were starting to understand the genetics and genomics of cancer. One was the TCGA, which was for adult cancers, and then there was a pediatric funded effort to understand the genomics of pediatric cancers called Target. And because of the work of the Quad W office and honestly the advocacy of the Titcheners and the Quad W office, osteosarcoma was one of the tumors that was included in the Target project. And this, massively parallel sequencing data that was generated off of tissue from patients with newly diagnosed osteosarcoma is now publicly available and usable. So investigators like me can download this data and do our own analysis on it, which is really phenomenal. And this is just an example of a couple of one paper that was like a secondary analysis of the Target data on the left that's already been published, a project on the right that Katie Janeway has led, that's a project in the works that also utilized some of the osteosarcoma data. And actually the hypothesis for this paper was based off of the results of the Target study. And then while that was Target was clearly an NCI promoted COG enabled project, I think it'd be a mistake not to point out that some of the landmark studies for the genomics of other sarcomas, including Ewing sarcoma and rhabdomyosarcoma, also utilized osteosarcoma samples from the COG repository, including one of the first studies in Ewing sarcoma by Javed Khan's group, one in rhabdo also from his group, and then Jack Shern has led some follow-up work that really shows beautiful risk stratification for some genomic features of rhabdomyosarcoma. So, this is just immense impact if you really think of it. A few other really interesting studies have come out. This is the immune landscape of osteosarcoma. So this is the cell types that are inside an osteosarcoma tumor sample that, a lot of us are hoping immune therapies might unleash some of these immune cells to help with treatment and sometime in the future. This is a study from investigators that showed that there are a bunch of inherited genetic variants that may be associated with a risk for developing osteosarcoma. And of course, this is the kind of stuff that we need to know about in cancer predisposition clinics, where we can identify patients who have these variants and then screen them to try to catch osteosarcoma early when it's maybe more treatable. This is some work from my own lab where we found that you could detect circulating tumor DNA in the blood of patients with osteosarcoma, and that how much of it's there can help us figure out whether patients need more therapy or whether the standard therapy is adequate. And this has led to a multi-institutional study to really validate that work. And then, we're going to continue to collect really highly annotated tissue samples on the upcoming prospective trials for osteosarcoma at COG. Already open is a study that compares an open surgery to thoracoscopy in patients who have metastatic osteosarcoma. And then in the next few months, we're expecting to open a new trial for all patients with newly diagnosed osteosarcoma, where we'll collect tissue and a lot of clinical data from hopefully the majority of patients who enroll. We're expecting about 500 patients to enroll in that study.
Wow. Do you know roughly how many osteosarcoma samples are in?
It sort of depends on how you dice it up. So It's a number that's like impossible to give because, if you count every slide, then it's like millions. But if you count it by the case, some patients have more than one time point. So hundreds, definitely hundreds, probably thousands of cases in there. But it takes a pretty ridiculous proposal for us to say, or very specific, like we need a sample that meets all these conditions for us to say that we don't think we can meet the need. Most of the time, it's a matter of whether the investigator's preliminary data is robust enough and whether their hypothesis is powered sufficiently. When a proposal doesn't get approved for samples, it's usually not because we don't have enough samples in the bank. I mean, you just can't get any more samples than what COG has. So there's nowhere else in the world to get samples, that many samples of that magnitude. So what about being able to use the data? So how do we get more like the Iron Man computer program? So a while ago now, the Quad W office, before I actually was super involved with Quad W office, went out and tried to gather back the research data that was done on a couple of the bigger osteosarcoma studies that resulted from the tissue collected in the COG repository, just to see, are there overlaps between different projects? Do they include the same cases over and over again? And what they found is that, to some extent, yes, that multiple studies can, looking at totally different things in a tumor sample, might include the same patient. And so what they tried to do is say, come ask us for this data because we think it's useful. But it turns out that unless you make it easy for people to just look at the data, they don't tend to ask for it because they're not sure what form it's going to come in. They're not sure it's going to really meet the requirement. They can't play around with it to sort of say, is this going to meet my need? Is it not? So sure, occasionally a very motivated person came by and said, I want this data. But by and large, this publication didn't result in a lot of requests for data. And that was a little disappointing. But around the same time that we were drawing that conclusion that it was a little disappointing, groups are starting to come out with basically enhanced user interfaces where you could take complex data, put it in a graphical user interface, and that you didn't need to be a computer programmer then to play around with it and to do some preliminary experiments, virtual experiments with them to try to say, is there information there where I want to actually download the data and do a hardcore computer-based experiment on the data that already exists. So Yangji is an investigator at UT Southwest who specializes in this kind of work. And the COG and the Quad W office sort of recruited them and worked together with them to actually get them interested in osteosarcoma as a data set. And I think it became interesting because in part, like the target data is at the heart of the data set that they had access to. But they also have access to like most of the clinical data that COG has, and now multiple other studies we're trying to add in, and all of that HDD data as well. And they developed this tool called the Osteosarcoma Explorer that allows investigators to go in and sort of play around with the data. We've put my liquid biopsy data in, so it's just one example. You can look at outcome based on ctDNA results. This is actually a slightly outdated slide because I think that we had a little error in the data. It actually, the Kaplan-Meier curves look better than that in the real thing if you do the search now. But it allows you to sort of do your own little experiment without touching any tissue, without running any experiments, without spending a penny. You can sort of say, is there something here? And so that's resulted in a lot of visits. We've had, up to 1,000 visits already from interested investigators. Sometime around January, we started to require users to register just so that we had some level of protection about who is using the data that's there, although it's all de-identified, so you really can't do any harm if you access the site. But we've had, many registered users now, and actually Dr. Xi's team will actually do consultations if people are having trouble figuring out how to navigate the site. So you can ask them, I want to do this specific thing, and they'll help you with the data. So I think that's pretty exciting now that people have access to this Explorer. More and more data we're trying to put into there. Basically now anybody who generates sort of what we call big data from an osteo study, an osteosarcoma-based study from COG samples, we're trying to get that data back eventually, although it usually takes a while for them to generate the data and then publish it. Once it's published, try to get that data back and put it in here so that more and more overlapping studies can be done on a larger and larger group of patient samples. And that data is mostly focused on like tissue-based studies that are reasonably annotated. But of course, you can have really rich data, and if you know very little about what happened to the patient or the patient's characteristics, then you're limited on that side to how much research you can do with some of these results. And so we're also trying to help contribute to this project called the Pediatric Cancer Data Commons, or PCDC. This is a massive project run out of Chicago by Sam Volchenbaum, who is really the world's leader in this. And they're really being very careful about clinical annotations and defining exactly what it means to have osteosarcoma or to have this clinical feature, that clinical feature, very carefully defining outcomes. So that data basically gets harmonized across all of COG, and then they're doing this now on an international level so that basic clinical data now can be combined between patients enrolled on European studies and patients enrolled in US studies. And that allows obviously for much more power to make sort of a clinical discovery. So eventually the goal is to sort of get the research data in the Explorer to sort of talk directly with this harmonized clinical data that's available through PCDC, and the Quad W office also contributes to making sure the PCDC gets access to clean data from the COG.
Oh, we just had a question before you move on from Oscar. He was just generally asking about the Pediatric Cancer Data Commons, but he also wanted to know what were the biggest obstacles in centralizing the data. And he said, how can we as advocates help with it?
For the PCDC, that's really outside of my area of expertise, but I am quite sure that, this is really being led by Doug Hawkins, who's the overall chair of the COG, and Sam Volchenbaum, who is the PI of the PCDC project. I know they're very interested in patient advocacy. If you haven't had him on OsteoBItes, I honestly think he would be like he presented at Factor. He gave a great talk. He gives great talks. So
I'm making that note right now.
Okay, it might be worth having a dedicated talk. And I think asking him those questions, he's a pediatric oncologist. He's very committed to like sort of making things better so that more cures are found. And I think patient advocacy, he would find that very welcome, but I don't want to speak for him. I don't know exactly how he might put advocates to work to make things move even faster, but I'm sure he has ideas. He's brilliant. So he would be a great OsteoBItes presenter, I think. Any other questions before I move on to experiments? So if we're going to get samples and we want to generate data and we want that data to be accessible, the one thing we haven't talked about is how do we get experiments really moving? So, some of this just relies on having really great scientists interested in osteosarcoma. And we're obviously always trying to get people who are doing great work more involved in the really important problem of better therapies for patients with osteosarcoma. But we don't want to just like hope they come along. We're also, most of us who are involved in all these initiatives are also scientists ourselves. So one other thing that's come along is, the Children's Cancer Data Initiative. They're very initially focused on some brain tumors and some soft tissue sarcomas. So we're not going to wait for them to come around and sequence a bunch of osteosarcoma samples. So Katie Janeway and Nick Waggle at Dana-Farber applied for this NIH Moonshot grant to develop an osteosarcoma specific project in Count Me In. And this is basically a direct-to-patient research banking project where patients can just go to the website, self-consent, and then try to contribute their tissue if there's any left over to this massive sequencing project where we're going to try to sequence tumors and match germline samples and even some liquid biopsy samples, so that we can really understand what are all the subtypes of osteosarcoma, what predicts response to what. So it's really intended to be a pretty massive project. The initial project got launched, and now with the Moonshot funding, it's going to get relaunched. And during that relaunch, there's going to be a portion of the project where we actually are able to return results to patients of the sequencing. It's mostly returning the research results to patients in sort of like a research style report, but we will be able to return results, and germline results can get returned. So it's basically going to fill the gap that CCDI is not going to fill for osteosarcoma. So we're very excited. One of the things that we're going to try to do now is to make sure that everybody knows about this, is that we're going to actually look using Project Everychild. If we're going to look to see, are there any patients who've enrolled in Project Everychild who has osteosarcoma? Obviously, the answer will be yes. And then if they say yes to future research when they're enrolling on Project Everychild, then we can use that contact information to directly reach out to the patient and give them the opportunity to also enroll in Count Me In. So it's sort of this partnership now between Project Everychild and Count Me In that I think is going to be really super exciting. And then just another way that we're trying to accelerate experiments, both the Quad W and OSI are directly providing some funding for correlative biology work on those two clinical trials we talked about that COG, one open and one about to open for patients with osteosarcoma. So we are trying to also accelerate the experiments. And this is just the osteosarcoma project Count Me In homepage where you can go and learn more. The website's really simple, osproject.org. You can go there and register. There is the option of bereaved families registering here, which is one of the things I wanted to bring up in answer to your earlier question. I think there's still some work to be done to make sure everything's checked off and we have complete permission to get tissue samples from patients who have already passed away. But for sure, we can start collecting the clinical data, the self-reported data from the family members. the bereaved family members for part of this project for sure.
So back to Oscar's comment about how patient advocates can help.
Yep.
So definitely like enrolling in Project Everychild. And,
Yep.
and part of that, they might even get some sequencing back, right? That could help inform their treatment
Enroll in
plan.
Project
Oh, sorry,
Everychild.
take that back. They can enroll in Project Everychild, and then they can just sign up for the Osteosarcoma Project, and they can get the sequencing data from the Osteosarcoma Project.
That's right.
Thank you. Sorry about that.
If they don't know about Count Me In, then we're still going to probably reach out.
Yeah.
The return of results relaunch is still coming, so it might be a good time to not immediately enroll. I think in the next few months we're going to do the relaunch, and the relaunch will allow us then to do that return of results, because the original project was only for research sequencing without return of results. The relaunch should happen in the next couple of months, actually, and in which case it'd be a really great time to enroll. And we'll do all kinds of press around that and make sure people are aware of it. But it is one area where we're really hoping our advocates can let people know that there's now this next level of the Count Me In Osteosarcoma project that we're really, really excited about.
Great. So, but two things to enroll in that would be really helpful.
Right. That's right. And this is just sort of our envision of how I kind of think how at COG and Project Everychild, we make a big impact in a lot of different ways. Kids and their families, they contribute to this tissue, and we have an obligation to make the most out of that tissue and that data, so that in the future, cancer therapy is more effective and easier to get to a cure with less toxicities. And we're doing that by contributing data to the data commons and giving people an option to enroll in Project Everychild, and pushing any data out that investigators generate into a usable interface to the Osteosarcoma Explorer, and making sure investigators who have a good hypothesis and are doing good science have access to enough tissue. And we hope all that leads to better therapies down the road. I think that was my last slide. That last one just says questions and discussions. I think this is a prettier slide, so we'll leave that one up for now.
I just wanted to start with a question then. Someone asked, has the circulating tumor DNA blood biopsy been used for patients without metastatic cancer and after surgery of the prime tumor?
Yeah, that's a great question. So in the study we published in, we should start with the fact that at the moment we're doing this in a research setting. So we're not making clinical decisions off of liquid biopsy in osteosarcoma yet. But the goal of our ongoing multi-institutional study is to make sure that we validate that so that we can start making decisions off of it. The study we published was all samples from before treatment, because that was all that was in the repository. We used samples that were collected before anybody knew what liquid biopsy was, so we didn't have access to samples at multiple different time points. But in this study that is ongoing, we're looking at pre-treatment, early on treatment, and after resection to see what's most predictive of really good response. And can we identify patients who really should stop standard therapy because it's never going to work, and we need to put them onto something that maybe could be potentially more effective in the context of perhaps a clinical trial of some kind. So we are thinking about all those time points. We don't have a lot of data yet in osteosarcoma specifically about all those time points. In other cancer types, for sure, those changes in ctDNA over time and how those levels respond to treatment and whether there's anything left over after therapy have been very powerful at predicting whether we're affecting a cure or whether we're not. So I do think that, hopefully in the next 10 years, we'll be delivering all that information back to patients, but it's going to take some time and it's not ready to go today.
So related to that, if a patient enrolls in Project Everychild, will the institution just continue to send samples after, hopefully there aren't any further procedures, but if there continue to be procedures,
yeah,
will they just continue to send those?
It's allowed, but it does sort of sometimes come under the radar, right? So Project Everychild, they accept samples from upfront diagnostic biopsy samples, and then most patients go on after a couple of cycles of therapy in osteosarcoma go on to have a local control. Usually by the time you get to local control, the institutions have sort of lost attention to banking. So it is an opportunity for patients and advocates to remind their docs, hey, don't forget, send a little bit of that into the COG. Even more so if a patient has a relapse, because you know, it's a horrible time and a lot of stuff is going on and people are trying to figure out what the next steps are. So it definitely flies under the radar that those relapse samples actually are incredibly precious and super informative and really valuable. Like, we don't understand how tumors, you know, go from being responsive to therapy to then down the road after relapse, sometimes they're very resistant. We don't know what changes. Like, why doesn't the same chemotherapy work the second time around? It doesn't usually. So we have to figure that out. And if we don't have any of those relapse samples in the bank, we're not going to be able to figure it out. So that is another place where I think patients and advocates can really remind physicians, hey, I want some of my relapse sample going to research, either at COG or if there's a local effort at your institution.
And how often, what about the blood samples though? How often on the
Project Everychild alone, it's just at diagnosis and then at a progression or relapse. But again, that's a super valuable, that's the most valuable time point, because we can sometimes do deep sequencing on samples collected at relapse that are just as good as a biopsy. I mean, that's how crazy sensitive the technology is getting to be. On the clinical trial that's coming up, where, you know, we're going to enroll 500 patients with newly diagnosed osteosarcoma in the next like 5 to 7 years, which is most of the new osteosarcoma diagnosis in North America. There we will ask, in the context of that clinical trial, we're going to ask for, I don't remember whether it's 5 or 10 time points, but it's multiple early time points after surgery, and then later on, if there is a progression for that time point as well. So we'll have very granular data about liquid biopsies from that specific clinical trial. The problem with trying to do that in a biobank is that if you get all these different time points, but you don't have all the clinical data to go with it, you can't really make much out of it. And it's very hard to sort of contribute every single time point in the clinical course unless you're enrolled in a clinical trial, where the CRCs are literally being paid to go in and like pull all that data out of the electronic medical record, because it's needed to really see what the results of the clinical trial are. So it's really the best context to do serial kind of studies.
Got it. I have like 20 other questions, and I know we're almost out of time. I'm going to try to sneak in one other question, because I know we were chatting about this before, that it is, you know, it's kind of a process for a researcher to request samples, where we're saying, right, because it is such a finite resource, it's a limited, precious resource.
Yep.
And so I'm wondering, for the samples that do come in, is there any effort to generate cell lines, just because that's kind of a way to like maybe maximize that resource a little bit more?
Yeah. So one of the things we're doing, it's very hard to get viable tissue in real time, because especially if a patient's enrolled after the biopsy, when they find out what they have, then it's, you know, like it's no longer, it's either fixed or frozen, or like, well, hopefully it's fixed or frozen, otherwise it'd be dead, right? So, you know, the tissue can't live outside the body. So what we're doing is actually asking for viable tissue in the context of the upfront osteosarcoma study. And there, like every sample that comes through is going to go to a lab that specializes in making models in osteosarcoma. So Alejandro Cordero's lab in San Francisco, where he's done this extensively, is going to get whenever possible. And it's going to be a small portion of the patients to enroll, but whenever possible, we're going to ask pathologists to take a piece of the core, plop it into some culture media, and ship it overnight across the country to the lab, where they'll try to make a model from it. So we're going to try to do that for sure.
Got it. That's awesome. That's
that effort to sort of do all that shipping and all that, that's going to be, it's expensive, and it's going to be funded by the OSI, which is great.
Thank you, OSI, who's also our sponsor for this episode.
Perfect. All full circle.
It is. So thank you so much. And again, thank you for taking the time to talk about this. And I'm glad that it's something that we can share also with all the patients and caregivers on this call, because it is like a really tangible way that we can contribute and help. So thank you, Dr. Crompton, for joining us on OsteoBItes today and making it better for pediatric oncology patients everywhere. More information on this and all OsteoBItes can be found on YouTube, on our website at mibagents.org, and on your favorite podcast place. And next Thursday, please join us on OsteoBItes with Dr. John Ligon. He is an assistant professor at the University of Florida College of Medicine, and he's also one of our 2022 Outsmarting Osteosarcoma grant recipients. He's going to be talking about his work that is being funded by the grant, using RNA nanoparticle vaccines to overcome the immunosuppressive tumor microenvironment of canine osteosarcoma. Thank you again, Dr. Crompton and Vicki, for spending an hour with us today, and to our sponsor, the Osteosarcoma Institute. And thank you for joining us today on OsteoBItes. We hope to see you next week when we chat with Dr. Ligon. And in the meantime, please go to our website at mibagents.org to sign up for Outrunning Osteosarcoma. You have through September to do that. Thanks so much, everyone. See you next week.
Hi, everybody. Thank you.
Bye.